Students, once again I welcome you back to my class. So as you have already completed work and energy, so it's my turn to finish the last chapter of your physics syllabus, and the chapter name is your sound. Okay, so let's begin with this chapter. So first of all, what is sound? So in your previous lesson, that is work and energy, you have learned about different forms of energy, isn't it? Light energy, heat energy, then your mechanical energy. In mechanical energy there are two types of energy, the kinetic energy and the potential energy. So this sound, this one is also a form of energy. Okay, so the definition of sound will be, it is a form of energy which gives us a sensation of hearing. So this sound is a form of energy which is sensitive to our ears. That means it gives us a sensation of hearing. Clear? So now what are the properties of sound energy? Properties of sound. Number one property, it is a longitudinal wave. It is a longitudinal wave. Okay, I will discuss about this later on. It is longitudinal wave. This one I will discuss later on. Number two, it requires medium to travel. That means sound cannot travel in vacuum. Number three, speed of sound. Speed of sound in air is, it is around about 332 to 340 meter per second. This result may vary, but on an average it can be taken as 332 to 340 meter per second. Clear? Okay, next is, how is sound produced? Okay, how is sound produced? So sound is basically produced by vibrating objects. Sound is produced by vibrating objects. Okay, so examples like when you pluck a guitar string, sound is emitted. When we talk, the vibration of our vocal cord produces sound. Example, plucking of guitar string. Okay, when we pluck a guitar string, the guitar string starts to vibrate, and this vibration produces what? Sound. Next, vibration of vocal cords. Okay, the vibration of vocal cords produces sound. That means we talk when the vocal cord vibrates. Clear or not? Now we shall discuss about how does sound propagate through a medium. Okay, that means how sound energy flows through a medium. What is the process? So before learning the process, we should know what is waves. What is wave? Okay, wave, generally we can say this one as energy also that travels through a medium. So wave, you can say it is the disturbance that flows through a medium due to repeated periodic motion of the particles of the medium, which is the disturbance that flows through a medium due to repeated periodic motion of the particles of the medium, which is handed over which is transferred from one particle to another. Okay, it is the disturbance that flows through a medium due to repeated periodic motion. Now what does this mean? Periodic motion means vibration. So due to repeated periodic motion of the particles of the medium, which is transferred from one particle to another. Okay, the particles do not move forward. Themselves. Okay, the particle do not move forward themselves. Clear? It is not the particle that moves forward. Means we know that the particles, when wave is a disturbance, we can say wave is the energy also, which flows from one point to another point in the medium. But the energy, how does it flow? It is when the wave flows, that means what? A disturbance is produced in the medium. Due to this disturbance, the particles of the medium starts vibrating. It starts vibrating, and this vibration or this disturbance is transferred from one particle to another. One particle starts vibrating, so this disturbance is handed over to the other particle. This one also starts vibrating. This disturbance is again given to another particle. That one also starts vibrating. In this process only sound or the energy flows, but the particles only vibrate about their mean position. Okay, so the particle do not move forward themselves. That means from the point or the source where the sound is produced to the destination where it is about to reach, the particle do not move. It is the energy that moves. Okay, the particle only vibrates about their actual position or their mean position. So here it is the disturbance that flows through a medium due to repeated periodic motion of the particles of the medium, which is transferred from one particle to another. The particle do not move forward themselves. But only the disturbance only the disturbance move forward. Okay, so it is not the particles which move forward, it is only the disturbance that is moving in the forward direction, means from the point, from the source to the destination. Clear? Now let us learn about the types of waves. There are basically two types of waves. The types of waves are transverse and longitudinal. Transverse and longitudinal wave. So what is transverse wave and what is longitudinal wave? In transverse wave, I am writing the definition here only. The particles of the medium, vibrates normally to the direction of propagation of wave. Okay, transverse wave, the particles of the medium vibrates normally to the direction of propagation of wave. Now what does this mean? Suppose this is the direction in which the wave should travel. The particles, that means it is traveling through a medium and the particles will vibrate normally, that means perpendicular. This is the vibration of particle. The particles will always vibrate at right angles. It will vibrate at right angles, the wave will flow in this direction. Okay, so these type of waves are called what? Transverse wave. Like example, you can say vertical jerk on a stretch string. Whenever you take a string, okay, you fix one end and on the other end you just give it a vertical jerk like this. So along the string waves will be produced and that waves are what? Transverse wave. In the next one, longitudinal wave, the particles vibrate in the direction of propagation of wave. The particles of the medium vibrates in the direction of propagation of wave. Okay, so here if this is the direction of propagation of wave, the particles of the medium will vibrate above the mean position like this. In this way it will vibrate. This one. It will always vibrate in the direction of the propagation of wave. Clear? Here the particles of the medium will vibrate perpendicular to the direction of propagation of wave. Here you see, in this the particles will vibrate perpendicular to the direction of propagation of wave, but here the particles of the medium will vibrate in the direction in which the wave is traveling. This is the direction of wave. So the direction in which the wave is traveling, in that direction only the particles will vibrate. So this type of wave is called a longitudinal wave, and in this chapter we are going to study about this wave only because we are going to study sound. So example is sound. So sound is basically what? A longitudinal or a longitudinal wave. Clear? Okay. Okay, so here is a short note on the propagation of sound through a medium. So here we see, when an object vibrates, it sets the surrounding particle of the medium vibrating. The particles do not travel all the way from the vibrating objects to the ear. As I have told you that it is not the particle that will travel from the source to the destination, that means from the source to the ear. Okay, it is the energy that travels. It is the wave that travels from one point to another. The particles will only vibrate about their equilibrium or mean position. So the particles do not travel all the way from the vibrating object to the ear. The particles are displaced from its mean position and exerts a force on the adjacent particle, which also starts vibrating. Okay, that means one particle starts vibrating, it exerts a force on the neighboring particle, that one starts vibrating, again that one will exert a force on its adjacent particle, that one will start vibrating. In this way the disturbance is carried forward. Okay, this process continues in the medium till sound reaches our ear. So you have to write it down. This is about the propagation of sound through a medium. Clear? I forgot to give you one definition, the definition of vibration. What is vibration? So the definition of vibration is, it is the to and fro motion of an object. Okay, suppose this is a particle. If it undergoes a to and fro motion in this way, so this motion is called what? A vibration. And this point from where it starts vibrating, this middle point, this one is called the mean position. Okay, this is called the mean position. And the maximum distance, it goes up to this much, then it again comes back, then it goes here, it comes here, again it comes back. So this process continues. And this to and fro motion of an object is called vibration. Clear? Now see here, how does sound travels through a medium. This diagram is already there in your NCERT book. So see this diagram, this is a tuning fork. Most of you have seen this tuning fork. If you have gone to an ENT specialist, that means a tuning fork is basically used. It is given a jerk and then it is placed in front of our ears by a doctor to see whether there is any problem or not. Okay, a tuning fork produces a sound. Okay, so here you see what happens when this tuning fork starts vibrating. Suppose this tuning fork is set to vibration. What happens when it moves forward? When the vibration is in this direction, the air molecule that is in front gets compressed. Clear? Understood or not? When the tuning fork moves forward, that means in vibration there are two, means forward and the backward movement. So when the tuning fork moves forward during vibration, the air particles near the tuning fork, the adjacent, the surrounding air particles gets compressed. Okay, now when the tuning fork again moves back, at that time the particle gets, they spread out. This compression, this region is called, when the particles come forward, there is high pressure in this region. high pressure or density, you can say. It creates a region of high pressure or density. It moves forward. Then when this tuning fork moves back, there is a region, this region is produced. This region where the particles becomes well separated from one another. This region is called, this region has low pressure. Okay, so first of all, in this region all the particles comes close. When the tuning fork moves forward, all the particle comes close. Now this compression moves ahead, and then the tuning fork moves back. When it moves back, then the particle becomes separated from one another. The region that is produced becomes a low pressure region. Okay, so in this way, now the rarefaction again moves forward. Again this particle moves front. Again it gets compressed. All the particle comes close. Then again a region of high pressure is produced, which is also called compression. It moves forward. Again this one moves back. Again the particle becomes well separated. So again we get a region of low pressure, which is also called rarefaction. In this way, this compression and rarefaction, the disturbance, that is the compression and rarefaction, will travel through the medium to the destination. Okay, so this region of high pressure also called compression, and this region of low pressure is also called rarefaction. Clear? We will discuss more things about it in our next session. Okay, so that's all for today. Thank you.